Hey all, and welcome back to Radical Slice. My name is Eric. We are nearing the end of my little project to implement a basic brawler in Pico-8, reminiscent of the old NES game Kung Fu, but with a botanical spin on the aesthetic. Last episode, we started working on like a victory screen. So when the player finishes the game, we display a little message and play a little music to congratulate them for finishing the title. I'm actually working on finishing this up right now, as you can see. So we'll close that out first, and then we're gonna work on a couple more graphical effects before we wrap this darn thing up. Let's take a look at how the fade in is working. So yeah, you're looking at the finished product, but if we let it play through, we'll see that it sort of starts completely in shadows, and then there's sort of like a halfway point before it goes full color. Let me play it again. Okay, so this wasn't too difficult to get working, but it involves a little bit of coding trickery. So let me sort of show you what's going on there. So in my victory init function, initially what I'm doing is just resetting the player object because the player is, at this point it's going to be floating around on screen somewhere. We're not really sure where, but we need to get the player into position so he can walk onto screen. And so that's kind of like what all this little setup stuff is doing here. Some of it might be redundant, but yeah, it's kind of getting it set up. Then we set the global update function to be our victory update, which is pretty simple right now. I won't worry about the details of that for now. The really interesting bits are with the draw functionality. So you can see we have three different places where we're setting the draw function to something else. And each time we're setting it to this victory draw call, and we're passing in different arguments each time too. What's going to happen here is we're going to set the whole, in order to do the fade in rather, we're going to set all the colors to black initially. And then we're going to selectively choose some colors to make not black so that they look like they're slowly fading in. So for this initial phase, you can see it in Pico-8 right here, we've decided to take our light blue sky color and make it kind of like this funky purple color. And that allows it to kind of look like it's fading in a little bit at a time, right? We sort of like gradually tweak the colors. And that's why we have multiple calls here. The sky is normally color 12, which is light blue. We're going to first choose the light blue, and we're going to replace that with purple color. Everything else though is going to stay black. Then for the next stage of the fade in, like this, we're taking our orange color here, which we previously were setting to black anyway, but we're going to set that to be kind of a brown color. So again, you can see how orange, the slightly darker orange, I guess, is brown. I don't know. And also, again, we're going to make the sky a little bit lighter, right? We're going to say, instead of light blue, don't make it that purple color, make it kind of like this cool lavender color. Right? And then finally, we pass in an empty list of tables to say, like, don't replace anything with anything else. This will cancel out the black, the sort of blacking out of the colors as well. And it'll just allow the colors to be drawn normally. If we have a look at the actual victory draw function here, this is what's doing it. So you can see here, we do a quick check to see if there's any values being passed in our little sequence here. If there are not, if the length is less than 1, then we don't do any fade stuff and we just draw the screen normally. However, if there are any values, that means we're trying to do a fade out. So the first thing we do is we just black out the whole screen. And then we're replacing a couple of colors based on those values here. That's what allows us to specify. It's kind of limited because I only am allowing myself to replace 2 colors at a time. That's why there's only these 2 calls to PAL. But it does give us a pretty decent effect. So the way that the reason that it works in stages is because I have these 2 timers that are running, right? And so the initial call to draw is going to be playing for 1 second, and it's a sort of blacked out purple sky situation. And then after 1 second, we replace the call to victory draw up here, the blacked out one, with a couple of replaced colors, the slightly lighter sky, that one. And then after another half a second, remember this is 1 second here, this is 1.5 seconds here, we again set the draw function to be victory draw with no arguments, which means we're going to skip all the fade stuff and just draw it normally, which is what allows this to just draw with the normal colors. I've used this approach, I think, earlier in this series, but if not, allow me to just go over it again really quick. So when we have this sort of draw function up here, our global thing, this needs to be a function because this is going to be called by Pico-8. Right? So that's why what we're doing here, our victory draw function is actually like a nested function. If you have messed around with other programming languages, you probably know this is like a partially applied function, where we take in our sequence to the call to victory draw, and all we do, we don't actually execute anything. We don't do anything. We just return another function. And here, like, it's basically like if we said, if we had sequence in scope here, and we just had the value, right? So that's what allows us to set different values for the fading colors and still return a function that can be assigned to draw. If we didn't do this partial application, let's say we just we remove this return line here, what would happen is we'd have no way to pass these values in and have them, like these values up here, we'd have no way to pass these values in and have them remain in state for the later eventuality for this function actually being called when the main game loop calls draw. In this way, what we're doing is we're sort of cheating a little bit. We take our sequence value and we can sort of throw them in the saved state of this victory draw function. And then when we want to change those values, we just call it again, which returns a new function with the new values also in scope. So a little bit of function trickery, and I apologize because my explanation I know is not great. If you want to dig in a little bit more, you can look up partially applied functions or function currying. Yes, like the food, or the programming, or the famous computer scientist, Haskell Curry. That I'm sure you'll be able to find a much better explanation for this than I have given you. But yeah, basically our goal here is to just return a function that can be called with draw. And since we need to keep some values in scope, we're using partial application to do that. So that's the fade in. We also will need to do something similar for the fade out. So I will do that separately, and I'll just show you how it looks when it's all done. All right, so I implemented the fade out in addition to the fade in. I'm going to show you how that looks right now by just walking to the right. That was the level 2 boss I just beat here. And there we go, nice little fade out, fade back in. I updated the text. And well, I don't have the sound playing for Pico-8 right now. I wrote like a little fanfare for the victory screen. So yeah, the music kind of fades out and then the fanfare fades in. If you want to check it out when the game goes up on itch, I encourage you to play it. But yeah, it's just a little 5-second like boop boop kind of thing. So anyway, yeah, I'm pretty happy with the way the game ends now. So I think we can call the fade out and fade in part finished. I guess I should say I've opted to not do the leaves falling from the top thing just because, like, I don't know, it seems like a little bit too much. I'm good with what we have here. I think we can just go with this as the final screen, and maybe I'll add like a quick, press button to restart thing. But otherwise, yeah, I'm pretty stoked about this. I think we can leave it as is. In order to build up the effect of enabling the overdrive in little stages, the first thing I decided to do was to kind of stop the on-screen action when the player turns on the overdrive. I did this with a really simple change to the code, which I'll highlight right here. That's the whole thing. So this is the part where when the player presses the up key, assuming they meet all the conditions to turn on the overdrive, we turn it on, and because this is just toggling, right? This line of code is just a toggle. So we say, okay, well, if the overdrive is turned on, then we switch our update loop to be timers only, which means nothing else is going to be moving on screen. And we add a little timer to switch that back to the regular game update in half a second. And what we would expect to see here is the game action would just freeze for half a second, during which we would, play a sound effect and do a bunch of other visual excitement to indicate that, the overdrive is on. So we can have a look at what that looks like. So notice that as I walk to the left here, and as some trees appear to the screen on the left side of the screen, I'll tap the up key, and that will stop the trees in their tracks for just a second. And that's kind of like the instant where we're going to add some extra magic, right? So it just, it was almost imperceptible, but it was there. We stopped them for just a minute. So that's where we're kind of, maybe we'll add our particles and our sound effect. The next change I think it would be cool to make is to have the player do a little bit of a pose when they turn the overdrive on. And thankfully, we just added a pose for the victory screen, for like the final screen. We have this pose where the player is just holding their arm up in the air, like, yeah. And that kind of seems like an appropriate pose for like a power up thing. So what I did was turn off the highlight there. It was just add a change state call at the same time that we set the update function to be timers only. So again, same part of the player update code. We'll just change the player state to victory because the update function for victory doesn't do anything, but the draw function will make sure he draws with the correct sprite. And then along with resetting the game update, the main game update loop to be the game update function, we'll change the player's state back to stand. I don't think that'll cause any difficulties in terms of like weird state happenings, since they can't really be crouching and turning the state on very easily anyway, at least not with a controller. So we can see what this looks like. So again, just as I walk to the left here, I'll tap up to enable overdrive and you'll see the player hold his fist up victoriously just before annihilating the trees. Okay, so that's a nice increment, I think. In order to make the overdrive enabling bit even more interesting, I thought of like adding some particles. And so my initial pass, I'm not super happy with, but let me just show you what happens. So when I press up, he'll do the pose and so there'll be some particles like, whee! So that's kind of cool. It looks kind of like he's throwing confetti, which I think is not exactly what I'm going for. So I'm gonna play with this a little bit more before I finalize it. But let me show you kind of how the code looks. So when we, in the same block of code where we're like enabling the state change to victory, I'm just adding, I have this like fx.parts for particles table, and I'm just adding new entries to it with an initial X and Y position, and then a set of colors. These are just color indices that will be chosen from randomly when we create a new particle. You can see I'm giving preference to, is that red or orange? Number 9. Number 9? That's orange, right? So there'll be, because we're gonna pull like one color randomly when we create these particles, orange will be favored here. And then there's some initial velocities, and these two flags are just to kind of like play with the velocities a little bit to make them initialize a little bit more broadly. So you get like a bigger spread of particles, and then a gravity setting. So it's not super important what these values do, but we're just adding some particles here. And then the particle code itself is pretty straightforward. I don't want to get too deep into it, but you can just see whenever we call update, we're updating the X and Y coordinates based on the velocities with some limits in here to make sure it doesn't get too out of control. And then the draw function is just, I'm using pset, which is just drawing a pixel to the screen of whatever color the particle is, right? So this particle code I've brought in from another project I did, and it's not exactly what I want, but it's serviceable, and it doesn't use too many tokens right now, so I'm kind of just, I might use this as an opportunity to refine it a little bit. The one thing that maybe is notable, though, regarding particles is that during the victory pose, let me jump back there and demonstrate that one more time. You notice that everything stops, except the particles, right? The particles still go. We'll do it again. We'll do it again, but bigger. Hold on. There you go. So you can see the trees stop, but the particles go. That's because in the sort of timers only update function, which is the update loop that's being called when we're doing the victory pose, I'm allowing the particles to update. So they'll still be displayed. I thought that was kind of cool because it's like, you know, time stops except for everything around our player character, our hero character. So I don't know, it made them feel more powerful as they're launching a handful of confetti into the air. So anyway, yeah, so I think I might want to try like rather than the sort of confetti particle look, what I might want to try is like maybe like some larger circles that sort of dissipate the longer that they're there. Sort of simulate, I don't know, like smoke or like a little explosion around his hand a little bit. I'm gonna try iterating on this and I'll be back. All right, so I'll include a link to the Lazy Devs episode where they kind of implement the puffs, puffs or puffs of smoke. But I changed the particles to look a little bit like this, so they're kind of like big circles that sort of slowly fade away. And we can kind of take a look at the code and show you how I did that. I expanded the amount of data that's being held onto by each particle object. Before, particles had a single color, but now it's actually holding a whole table of colors. And the reason for that, well, you could probably guess because you can see how the puffs like change color in our example here. The other stuff that we added was, in addition to just having a TTL, there's also a max TTL, and you can see they're initializing to the same value. So this value is just going to count down here, and max TTL is just so we can remember what we started at. So that's going to be important for a couple of different reasons. Same thing for size. So we're passing in an initial size, and that will slowly decrease, which is what allows the sort of puffs to gradually dissipate like that. And same thing for max TTL, we're keeping track of the initial max size, which will come into play later. In the draw function, previously we were using this pset function, right, to just set a single pixel at a single x and y coordinate and giving it a color. Now, let me skip this line, I'll talk about that in a minute. Now we're using the circ fill, which draws a filled circle, as you can probably imagine. Again, at a position with the radius, which is our size here. And we're gonna just like grab a color. And this isn't random, right? Like before we were using rand to do some of the color stuff, but now we're actually just calculating some index and then using that. The way we're calculating it is by looking at the current TTL of the particle and comparing it to the max TTL and doing some basic arithmetic to just like grab the color that we want. So what that's going to end up doing is kind of like working its way through a list of colors that we pass in. And that list of colors that we pass in from the player is right here. And I've translated it to actual colors. And we're going to walk backwards through this, just the way the math works out. So the first couple of times we paint the pixel, or I'm sorry, the circle, it'll be pink. So we want pink to last a little bit longer. And then we'll move to orange, and then red, and then light gray, and finally dark gray before the circle disappears. And you can sort of see that if we set the TTL to be super long. So let me do that to give you a demonstration so you can see how the colors change. And you'll also see the size change, which I'll explain in a minute. So if we slow everything down and we give the puffs of smoke 5 seconds, right now, I think I was setting them for like 0.8 seconds. So if we give them 5 seconds, that's going to slow down the color change and also slow down the size shrinking. So this is kind of what it looks like. So you can see they're going to move from pink to orange to red to light gray to dark gray before they finally disappear. So you can kind of see what the effect is of that little bit of calculation that we did. Okay, I lied. One other thing that I wanted to add was when you're sort of running out of overdrive juice, that the player will flash just briefly to let you know that you're running low. And there we go. I added that. That's all. That's all we're gonna do. I'm done. I'm done now. I swear I'm done. And the way I did that, it's very similar to how I've done the other sort of flashing effects. Is I'm doing the palette switch to make the player pink when they turn overdrive on, and that holds out as long as there's more than 1 second of juice left. However, if there's less than 1 second of juice left, and that counter, because it's basically like an amount of time remaining. We do some arithmetic and a modulus of 2, which means like it'll flash a couple of times after it's below a second, is the result of this. The reason why that happens is because if this arithmetic ends up being greater than, or sorry, equal to 0, it won't do the palette swap, and so it'll flash between like the pink and red versions of the player. So anyway, yeah, one small final change to the overdrive stuff. Now I'm done. I swear I'm done. I'm not going to add anything else to this probably until next week. But I'm happy with this now. All right, that's it. All right, all that is it. The next video that you see from me will be a full-blown retrospective, post-mortem, whatever, about this project, and it will coincide with uploading this thing to itch, so you can all play it. Although if you just go to my GitHub, you could just grab it. But for those who are less inclined to be on GitHub, it'll be up on itch pretty soon. And thank you again, not only for watching this episode, but for everybody who followed along. Thank you for all the time you invested in this channel. I really do appreciate it. I don't know 100% yet what the next project will be, but there is one in the works, in the oven, or in the microwave at least. It might be a sort of a frozen, might be defrosting a burrito right now. We'll see. But yeah, I will catch y'all soon and look forward to that retrospective video. And bye for now.